In this video, we will learn about classification of acids. Acids can be classified in many ways. The first one is on the basis of their sources. So we have organic acids. So the acids derive from living organisms such as plants and animals. They are called as organic acids. For example, tomatoes contain oxalic acid, lemons contain citric acid, ants make an acid called formic acid. The name formic acid comes from Latin word formica, which means red ants. Here, the sources of acids are, this is citric acid produced by lemon, then we have oxalic acid, then we have malic acid present in apple, then we have tartaric acid present in the tamarind, lactic acid in the curd, ascorbic acid in the guava, then formic acid produced by red ant. So these are different organic acids and their sources. So simply naturally occurring acids or organic acids, they are weak acids and they cause no harm to living organisms. Then we have inorganic acids. So these are prepared from mineral sources and are therefore also called as mineral acids. For example, sulfuric acid, hydrochloric acid, nitric acid, phosphoric acid, they are some common inorganic acids. So on the basis of their basicity. Now basicity of an acid is defined as the number of hydrogen atoms in one molecule of the acid that can be released as H positive or H3O positive ions in an aqueous solution. So it can also be defined as the number of replaceable hydrogen atoms in one molecule of the acid. The first is monobasic acid. Mono word suggests means that it means one. So those acids which on complete ionization in aqueous solution give only one hydronium ion or H positive ion per molecule of the acid. These are called as monobasic acids. For example, we have HCl, HNO3, HICS3, COH, etc. They all on reacting with or basically on dissolving them in aqueous solution produces one H positive ion which will react with water to give us hydronium ion which is H3O positive ion. So monobasic acids ionize in one step. Therefore, they form only one type of normal salt. For example, HCl on reacting with NaOH produces NaCl plus H2O. So HCl can only form NaCl with NaOH, that is one type of salt only. Remember that basicity is not the total number of hydrogen atoms in a molecule, but it is the number of H plus ions which are ionizable. So hydrogen atoms which are specifically ionizable, they contribute towards the basicity of the molecule of the acid. For example, acetic acid, which is CH3COH, it has 4 H atoms in its molecule, but only one H atom is ionizable or it gives H3O positive or hydronium ion in aqueous solution. Hence, its basicity is 1, not 4. Here is the reaction. CH3COH on reacting with water produces CH3CO negative along with the H3O positive ion. Now the hydrogen atom which is attached to oxygen will basically it is ionizable hydrogen atom. Why is it so? Because of the electronegativity difference. These three hydrogen atoms are attached with the carbon, but this simple one hydrogen atom is attached with the oxygen. So the electronegativity of oxygen is quite higher than that of carbon. So there is a great polarity in the bond between oxygen and hydrogen. That's why this hydrogen is ionizable, whereas the electronegativity difference between carbon and hydrogen is almost negligible. So the bond is not at all polar. That's why only one hydrogen is ionizable, which is the hydrogen attached with the oxygen. The second category is we have dibasic acids. Di means two. So which means that these acids on complete ionization in water produces two H3O positive ions or they release two H plus ions in the water. So per molecule of the acid they produces two hydronium ions. So that's why they are called as dibasic acid. Example we have sulfuric acid, oxalic acid, carbonic acid, and then we have sulfurous acid. Now dibasic acids ionizes into two steps. The first one is we have H2SO4 which on aqueous solution produces first of all HSO4 negative and one H3O positive ion. Then this HSO4 negative will further ionizes to give us SO4 2 negative ions along with the another hydronium ion. Also same for carbonic acid, it first of all produces HCO3 negative ion along with the hydronium ion. Then this HCO3 negative ion on in aqueous solution produces carbonate ion along with the H3O positive. So as dibasic acids have two replaceable hydrogen ions. Therefore, they form two series of salts, of which one is acidic salt and the other is normal salt. For example, we have H2SO4 on reacting with NaOH can produces NaHSO4, which is an acidic salt because it contains one acidic hydrogen, which is this one, and also water is being produced. Then H2SO4 on reacting with two molecules of NaOH can directly produce a normal salt, which is Na2SO4, which do not contain any acidic hydrogen, and two water molecule is being released. So same thing happened that similarly phosphoric acid is a tri-basic acid, means it has three ionizable hydrogen atoms. Now on the basis of strength, basically it depends on the concentration of H positive or H3O positive ions present in the aqueous solution. So we have strong acid, which these are the acids which ionize more or less completely even at ordinary dilution. Dilution is simply addition of water, thus producing higher concentration of H plus ion or H3O positive ion. So they are strong acids. So strong acids are simply those acids which ionizes a lot at ordinary dilution or on addition of less amount of water. For example, hydrochloric acid, sulfuric acid and nitric acid. They all on addition of ordinary amount of water, they will produce a lot H3O positive ions. Same happens with nitric acid as well. So the solutions contains almost only ions and ions. Then we have weak acids. So these are the acids which ionize partially in aqueous solution and they do not ionize completely at even high dilution. So on addition of a lot of water molecules, these weak acids do not give all their H positive ions. So they actually produce low concentration of H plus or H3O positive ion. So they are called as weak acid. For example, we have acetic acid, carbonic acid, formic acid. In fact, organic acids are weak acid. So CH3COH on addition of water produces CH3CO negative along with the H3O positive ion. But here is the arrow which is small and here is the bigger arrow. This small arrow suggesting that the reaction is not going in the forward direction, means the product is not forming a lot, whereas the reactant is more in amount. Thus, an aqueous solution of a weak acid contains molecules as well as ions. Then we have on the basis of molecular composition, which is the first one is hydroacid. So acid containing hydrogen and a non-metallic element but no oxygen, they are called as hydroacid. For example, we have HCl, HBr, Hi. They have hydrogen as well as a non-metal which is chlorine, bromine, iodine, but they don't have any oxygen atom. Then we have oxyacids or oxoacids. Acids containing oxygen along with hydrogen and some other elements are called oxyacid. For example, we have hydrogen, a non-metal and oxygen atoms. So that's why H2SO4 is an oxo or oxyacid. Then we have HNO3, H3PO4. They all are example of oxyacid. I hope it is clear to you. Thank you.